sets with special names. If you already know what each of these sets refer to, then you can safely skip this video. If not, please continue. The sets we've previously seen usually have a finite number of elements, and moreover, the elements contained in these sets have usually been real-world objects. In contrast, in mathematics, the sets we'll see will often contain an infinite number of elements, and moreover, these elements will usually be things like numbers and other similar abstract objects. Let's consider, for example, the set which contains all real numbers between 0 and 1, including 0 and 1. Notice that this set contains infinitely many numbers. It contains 0, 1, 0.61, square root 2 over 2, pi over 4, and infinitely many other numbers. Contrast this to the finite set that we've seen previously. In this case, because the set C is finite, we can exhaustively list out every element in C. So C contains exactly cat, dog, and Obama. In contrast, with an infinite set, there's no such way to list out exhaustively all the elements in the set. Instead, all we can do is somewhat clumsily describe in words what this set contains. Fortunately though, mathematicians actually have a more elegant and concise way to write down this set. This set can be written down as left bracket 0, 1, right bracket. This piece of notation here refers precisely to the set of all real numbers between 0 and 1, including 0 and 1. 0, 1 here indicates that this set includes all real numbers between 0 and 1. The left bracket here indicates that this set includes the number on the left, namely 0. Similarly, the right bracket here indicates that this set includes the number on the right, namely 1. If we wanted to write down instead the set of all real numbers between 0 and 1, but excluding 0 and 1 themselves, how would we write it? Well, we will again write down 0, 1, indicating that this set includes all real numbers between 0 and 1. However, this time, instead of enclosing 0, 1 in square brackets, we are going to enclose them instead in parentheses. The left parenthesis here indicates that we exclude the number on the left, namely 0. Similarly, the right parenthesis here indicates that we exclude the number on the right, namely 1. You can probably guess that if we wanted to write down the set of all real numbers between 0 and 1, excluding 0 but including 1, we'll write left parenthesis 0, 1, right bracket. Again, the 0, 1 here indicates that this set includes all real numbers between 0 and 1. The left parenthesis indicates that we exclude the number on the left, namely 0. And the right square bracket indicates that we include the number on the right, namely 1. Let's try another example, but now going in the other direction. What does the set left bracket 5, 17, right parenthesis refer to? Well, this refers to the set which contains all real numbers between 5 and 17, including 5 but excluding 17. Now what about if we wanted to write down the set of all real numbers? How would we do this? Well, it would be no different from before. We will just write down negative infinity, infinity, indicating that our set includes all real numbers between negative infinity and infinity. But we will enclose this with a left parenthesis and a right parenthesis. The reason being that our set here does not include the numbers negative infinity and infinity, as these are not real numbers. So this right here is one piece of notation for referring to the set of all real numbers. There is actually yet another piece of notation that can also be used to refer to the set of all real numbers. This is the uppercase letter R, which can be rendered in at least 3 different fonts. It can be written as a big fat R that you see here, or a fancy R like this, or a cursive R like this. So whenever you see one of these big R's, this piece of notation here refers precisely to the set of all real numbers. Let's now consider a different set, namely the set of all integers. One way to write down this set is to write down the list of all positive integers, so that's 1, 2, ellipsis. The ellipsis here indicating that we also include numbers like 3, 4, 5, and so on and so forth. But the integers also include the number 0, so we'll have to throw that in as well. And they also include all the negative integers, so we also want to include -1, -2, and again ellipsis. The ellipsis here indicating that this set includes -3, -4, and so on and so forth. So just like in the case of the real numbers where the big letter R stood for the set of all real numbers, similarly here the big letter Z is going to stand for the set of all integers. Z here simply being the first letter of the German word Zahlen, which means numbers. Yet another important set to know about is the empty set. The empty set is quite literally the set which contains nothing. It has 0 elements. And so in our usual notation, it will be written simply like this. There's left curly brace, blank space, right curly brace. The blank space here indicates, of course, that there is literally nothing in this set. So just like the set of real numbers or the set of integers, we actually have an alternative piece of notation to write down the empty set. This is given by this symbol over here. This is just an O with a /.